So I kind of accidentally showed this slide when I was trying to do that last pressure question, mostly because there was dirt on my screen and I couldn't really fix it without skipping on to the next slide. But now or never. Uh, in this section, this next concept we're going to be discussing is known as Boyle's law. So this was discovered by an Irishman, Robert Boyle, who did a lot of stuff with chemistry and especially thermodynamics. So, if you're the chamber full of air and you need to compress it, which means to reduce the volume, if you've done any sort of engineering, the compression stage of a car engine actually uses Boyle's law to an extent. Uh, if you compressed it, you'd note that actually the pressure inside would change. So, as you compressed it, reducing the volume, the pressure would actually go up. So actually, for this to occur, the number of molecules has to be fixed. So we can't actually add any impurities into it. So we can't say coat the bottom of a piston. If you've so a piston is sort of like this. You have a column in here, uh, and then the piston sort of compresses all the air. If you were to have, say, water in the end of this, we'd actually be introducing some new molecules. So in that case, this special law would not hold. In this case, Boyle's law would not hold because of the extra molecules. We'd also have to have a fixed temperature, and if the temperature was to change, we'd actually be using the heat equation, which I can't remember off the top of my head, but it does use partial differential equations, which I won't actually cover in this series. So, with this relationship, we can find that if the temperature and number of molecules are fixed, then the pressure has to be inversely proportional to the volume, which means that the pressure times the volume is a constant value. Those doing chemistry, you'll be familiar with the ideal gas law, which says PV is N or T. Uh, you can actually see that we have, again, pressure volume, and then N or T is the equivalent constant, which I've written here as K, but chemistry students will know it as N or T. Or, by the way, is known as the ideal gas constant, and it has a unit of joules per kilo or joules per Kelvin mole. Some people say joules per Kelvin per mole, but joules per Kelvin mole is actually how I say it. So when actually doing questions regarding Boyle's law, you have to remember that the pressure and volume at one point is equal to the pressure and volume at another point, given that all of the above is satisfied. So we have a fixed mass of gas at constant pressure, then the pressure times volume at the first point is equal to pressure times volume at the second point.